Hello guys and welcome to the GCE Math panel online, and in this lesson we are looking at the adjoint of a 3 by 3 matrix. In our previous lesson we looked at introduction to matrices and the determinants of 3 by 3 and higher matrices. Please stay tuned and follow this lesson to the end. Welcome to the GCE Math panel and to Math 24 Super Channel. The adjoint of a 3 by 3 or higher order matrix is obtained by the transpose matrix of cofactors. That is, given the matrix M with entries A1, B1, C1, A2, B2, C2, A3, B3, C3, then the adjoint is denoted M star or HM, and it is given by HM or M star is equal to the transpose matrix of the cofactors, where the cofactor of A1 is A1, of B subscript 1 is that. So when we have all of these cofactors for each of the entries, we now transpose to have the adjoint of the matrix M. So after having the cofactors, please don't forget to transpose. For example, find the adjoint of the given matrix. Find the adjoint of the given matrix. M equals that. So our adjoint will be given by the transpose of the cofactors of all the entries. So for the first entry, the cofactor is plus. At this position, the cofactor is plus because I is 1, J is 1, or it is an entry of the first row and first column. And from our formula, we have minus 1 to the power I plus J, or 1 plus 1, which is plus. So this now gives us the determinant of this remaining part here. When this one is covered, this column is covered, we have 3 minus 1, 6 minus 2. So let's see what we have. 3 minus 1, 6 minus 2. Now the next entry is this 2. So when we cover this column containing this 2 and the row containing it, we are left with the entries 2 minus 1, 3 minus 2. So we are left with, and this position is an entry of row 1 column 2. Minus 1 to the power 1 plus 2 is minus 1 to the power 3, and that gives us minus 1. That's why this cofactor here is negative. The next cofactor at this position will be positive because this entry is row 1 column 3. 1 plus 3 is 4, and minus 1 to the power 4 is positive. Normally, the cofactors alternate in their signs. So we expect this next one to be positive, and when we cover this row and column containing this entry, we'll be left with 2, 3, 3, 6. So let's see what we have. 2, 3, 3, 6. The next is this position. Since this one is positive, the next cofactor should be negative. And when we cover this row and column, we'll be left with 2 minus 1, 6 minus 2. The next position is positive at 3 now. When we cover that, we are going to be left with 1 minus 1, 3 minus 2. The next position is negative, and we will be left with the entries 1, 2, 3, 6. We have 1, 2, 3, 6. The next position is positive. This is at 3 now. The entries for that cofactor, we have 2 minus 1, 3 minus 1. Next position is this 6. And the entries that are left, the cofactor is negative here. And for the last position, we have minus 2. And when we cover this row and column, we are left with 1, 2, 2, 3. And we can now simplify this to have the following entries. We now transpose. Transpose means now we now interchange. We now replace the rows by columns. So row 1 becomes column 1, row 2 becomes column 2, and so on. So we have 0, minus 2, 1, 1, 1 minus 1, and 3, 0 minus 1. So this first row becomes the first column, the second row becomes the second column, and the third row becomes the third column. And this is how we obtain the adjoint of a 3 by 3 matrix or any other higher order matrix. Let's take some other examples. Example 2, find the adjoint of the matrix given. So our adjoint of this matrix will be the transpose matrix of the cofactors. The first cofactor here that we're looking for is this position 2, is positive. We are left with the entries 1, 1, 1, 2. The next is this position. We are left with the entries. When you cover this row and column, we are left with 1, 1, 0, 2. The next is positive. You cover that row and column, we are left with 1, 1, 0, 1. The next is negative. You cover the row and column, we are left with 0, 3, 1, 2. The next is positive. You cover the row and column, we are left with 2, 3, 2, 3, 0, 2. The next cofactor is negative. We are left with 2, 0, 0, 1. The next cofactor is positive. 0, 3, 1, 1. The next cofactor is negative 2, 3, 1, 1. The next cofactor is positive 2, 0, 1, 1. When we simplify these determinants, we obtain these results. And when we transpose, we obtain row 1 becomes column 1. So we have 1, 3 minus 3, or column 1 becomes row 1, and so on. And for the last column, we have 1 minus 2, 2. It becomes the last row. And this is our transpose. Some remarks on transpose. If the matrix M has order M by N, then the order of the or size of the transpose is given by N by M. Equally, A plus B transpose, the transpose of the sum of matrices, is equal to the sum of their individual transposes. The transpose of the transpose leaves the matrix the same. The transpose of the product AB is the product of the individual transposes of B first, then A second. So this last matrix comes first. The determinant of the transpose is the same as the determinant of the matrix. If A is a square and non-singular matrix, then the inverse of the transpose is the same or equal to the transpose of the inverse. Please answer the following questions completely. And don't forget to leave your answers in the blog or leave a link or a mail. You can visit GCE Math Panel online classes and leave your comments there. There are so many lessons and a lot of materials. Equally, if you like to buy this PowerPoint or any other material, you can get to us through that. Thank you so much. Welcome to the GCE Math Panel online and Math 24 Super Channel. The next lesson is on the inverse of 3 by 3 matrix, and many other lessons follow. Thank you so much. Stay tuned and don't forget to subscribe. Please don't forget to subscribe and answer these given questions. You can click on the WhatsApp link to discuss your answers. Thank you so much. I have been your host, Dr. Miles. Bye-bye.